M1 Kinematics, example 9. In this example, we've got a cyclist who's moving along a straight road with constant acceleration. She passes a shop and then 10 seconds later, she passes a street sign. The distance between the shop and the street sign is 60 metres. So first of all, she passes a shop. We don't know what that starting velocity was, but we know that 10 seconds later, she's travelling at 8 metres per second. So that's our final velocity. And we know that the distance between those two is 60 metres. First thing we need to do is find the acceleration. So thinking about the things we do know, we've got t, v, s and a. So we're thinking of an equation that involves all of those. And if you remember that fifth equation, vt minus half at squared. So we've got s is 60, v is 8, t is 10. And we've got a half times a, which we don't know, and t squared is 100. Okay, so we've got 60 equals 80 minus, well, half of 100 is 50. Okay, so I'm going to rearrange this. I'm going to bring the 50a over onto the left-hand side to make it positive. And then if I bring the 60 over onto the right-hand side, we've got 80 minus 60, which gives us 20. And so a is 20 divided by 50, which works out to be 0.4. Units, because its acceleration will be meters per second squared. We now need to know the speed with which you pass the shop. If you remember, the shop was at the beginning, that was the starting velocity. So we need to know u. So we've got t, v, s, and we want to know u. So probably the easiest one to use. I think we're on safe ground using this. I'm fairly confident that answer is right. So I'm going to use v equals u plus at. 8 equals u plus, I'm confident with my 0.4 being correct, so I'm going to use that, 0.4 times t. 0.4 times 10 is 4. Bring that over onto the left-hand side and subtract it. That means that our starting velocity is 4 meters per second.